We're continuing taking a look at sine and cosine and their graphs. So we've turned sine and cosine into functions. So we've taken the unit circle and we've stretched it out. We've now got an input is the angle, the output is the value of that ratio. But so it makes the curves that we saw in the last video. So we're going to talk about, I think we did some of this in the other video, it's been a while since I made that one, but we're going to take a look at finding the midline, amplitude, period, and phase shift. These are exactly the same things that you do when you do this just in a college algebra question with any function. They're the same things, they get some fancier names. Are we graphing this or no? Okay. So I'm going to call it a little bit different on a couple things. So my amplitude is my vertical stretch. Are we stretching or compressing vertically? That's always what's outside the front of the function. So that's 3 here. Now it's an absolute value. If this had been -3, our amplitude would still just be 3. Let's see here. Let's do the period next. Okay, so the period is always, for sine or cosine, is 2 pi, but that number in front of x is what you're going to divide it by. We're going to divide this by 2, and my period's going to be 5. So if you remember back to your college algebra functions, if you have a number inside there on x, it does the opposite of what you think. If you're multiplying this by 2, you think that this would stretch it, but it actually does the reverse. It actually compresses it. It makes it smaller. Or tighter might be a better way to go. So this is vertical, this is horizontal. So this does the reverse of what you would think. And what it's doing is it's taking the normal period, which is 2 pi. It takes 2 pi to repeat this function. It has now squeezed it tighter. And so now it's down to pi. Okay, and then the only other thing left, so phase shift, I would prefer just horizontal shift instead of phase shift, so we had the same language that we did in college algebra. So fancy name, but same thing. So horizontal shift, we aren't going anywhere this time. That would be if I had had something else in here with the x, a minus or a plus. So that we don't have any horizontal, but we do have vertical. So again, I'm going to just use the language of college algebra. I do have a vertical shift, it's up 1. So we're going up 1. Okay, now the only thing I didn't cover is the midline, but the midline is tied to that vertical shift. So the x-axis is what this graph is typically founded on, right there on the x-axis. Well, you could call the x-axis the line y equals 0. But we've now moved it up. We've taken that whole sine function and we've moved it up. So now it's centered around 1. And so the midline is that line running right through the middle, y equals 1. Okay, so let's see what else we got. We did all this. Well, here's a graph of it. So it's moved up. We got a midline now at 1. The amplitude is 3. And now, because our phase, or we have this horizontal compression, it's gotten tighter. Look, the whole thing repeats at pi. We go one whole phase, I guess, of the sine wave between here and pi. So we have one complete one. So every pi now we're repeating because we're tighter than we were before. Okay, let's play the game again here with this. Let me start with amplitude. So amplitude is just a vertical stretch or compression. It's exactly the same as it was before. On the outside, it does what you would think it would do. If you multiply by 1/2, you're thinking you're compacting this vertically, and you are. So amplitude is that same thing. It's the vertical stretch or compression. Ours is 1/2. Remember, it's only the absolute value. So this graph is going to go up to 1/2, down to -1/2, up to 1/2, down to -1/2. Now, before we go any further, I forgot to mention this. So I always factor this out so that we have x by itself. So I'm pulling out a 1/3. So let me show you what I mean if I haven't done this in the other video. So I want this to be in this form here. This will be my horizontal stretch or compression, and this will be the shift. If you leave it in this form right here, it gets confusing and you don't get the shift right. But if you factor this out here, then you have the compression, the horizontal compression or stretch right here is this number, and it'll help you find the period, and then you'll have the right shift. So I don't like this. I don't leave it like this. I factor out whatever's in front of the x. So I'm factoring out a 1/3. So if you think about that, if I'm factoring a 2 out of something like this, taking a GCF of 2, what I'm really doing is I'm dividing that second number. So here, if I'm factoring out a 1/3, what I'm really doing is dividing pi over 3 by 1/3. Okay, so if I factor that out, if you divide fractions, you keep the top one, change it, flip the other one upside down. That's how I got the pi. I'm just pulling out a GCF of 1/3. Now I did that so that this is now in the form where I can read everything I need. We're going to find the period. The period is always 2 pi. For sine and cosine, it's 2 pi divided by this number that's in front there. So what does a fraction do? It does the opposite of what you would think. It's going to stretch it horizontally by 3. Well, let's look what happens. 2 pi, you divide by that value in front of there. Well, if I have to do that, 2 pi, keep, change, flip, it's going to become 6 pi. So this function has now got a period of 6 pi. So because we had that 1/3 there, it's made it bigger. It has stretched it, 6 pi. Okay, now again, phase shift, it's fine language. If you're going on to engineering or something, I'm sure you should get used to that. But I like it to stay the same as college algebra language. So horizontal shift, we took this function. Remember, it is built with a minus sign. Like so, this is kind of counterintuitive. This goes right by pi. So I hope you remember that from the college algebra version of this. A minus sign means I'm going right. I'm going right pi units. Okay, so we don't have any vertical shift. So there's no up and down tacked on the end. So my midline is just going to be the original midline, which is y equals 0. Okay, now I think we've got a few more of these here. We're going to do the same thing, but we're going to do it from the picture. Now, in classes nowadays, I'm not asking for the formula to be done here. I'm just asking you to get the information off the picture. But I'll go through it all and I'll show you how you would find the formula here. So first of all, we want to find the amplitude. So if I look at this picture, the first thing I need to do is I need to see where could I fold this in half? Like where's the center line? Do you see if I folded the top down, I would get the fold, the edge of the fold would be right here. So in other words, I'm saying, what's the halfway point of the height? And it is 0.5. So my amplitude here is 0.5. Do you see that's the line that's halfway between the up and the down? 0.5. Okay, so I don't really need this yet, but my midline then would be y equals 0.5. They're not asking for that. They want the formula, but so let's go through there. Now here's the harder one. Let's find the period. Okay, so the period is where this thing repeats. So you could pick any spot, but let's start from here until we've gone through the entire shape of the curve and we stop again. Well, it's right here. So what's that length? How long did it take for this curve to repeat? Well, it's 2 pi. So the period is 2 pi. Okay, now here's what we need to do. The formula requires this number b. This is the horizontal stretch or compression. And so the way you find this, so if this is the period that we've established, we know the period for this is 2 pi. Well, the way you find the period is you take the 2 pi, that's for cosine or sine, and you divide it by whatever that number is in the formula. Well, I don't have the number in the formula. That's what I'm looking for. So I'm going to use this equation here. Well, I should do it like this. 2 pi over b is going to equal the period. Do you see what I'm doing? If I solve this, so I read the period off the graph, but I need b. Well, if I solve this equation, then I'll have the value of b. Well, in this case, obviously b is 1. Okay, so all of this to show you just how to find that b is equal to 1. Okay, now how about the phase shift, the horizontal shift? Hold on, I'm going to write our vertical shift too. I kind of skipped that. Okay, so our vertical shift, we went up, right? This graph is normally centered around the x-axis, so we've gone up by 0.5. So This has gone up by 0.5, so we're going to have a vertical shift. Now, what about horizontal? Now, what's weird about these is you could call these, because the shape is the same, you could call it a sine function with one shift or a cosine function with a different shift. They're the same shape. They could overlap. You could think of them many different ways. You could think of them as being something that's been flipped upside down. There's a lot of ways you could do it, and they would be right, which is another reason why I don't ask this on tests anymore. It's very confusing, but what we want to do is just find our horizontal shift here. So we're going to settle on, yeah, let's think of it as a cosine. Cosine's a little easier to read. So do you remember that a cosine starts at the top, goes down, comes back up to the top? So I'm going to think of this as a cosine, and the reason I did that is it's the easiest to read on this graph. So I'm going to think of this as a cosine function that has been moved forward by pi. Do you see that? I've moved forward by pi, and like I took the starting line for cosine, and I've now moved it to the right by pi. So that in my formula, that's going to be a minus pi. Now, you know what? When I did the amplitude, I'm not sure if I explained this correctly because I was thinking of something else. We have vertically shifted this up 0.5. Now, what's the height? What is the height from that new midline up to the top, and what is the height from that midline down to the bottom? I think I said that wrong when I first did it. It's 0.5. So we have an amplitude of 0.5, and we have a vertical shift of 0.5. We moved up 5, and it just so happens that's the same as our amplitude. Okay, so now let's build an equation. We're calling this a cosine function. It's got an amplitude of 0.5. Those go out front here. Now we need a value of x, or a b here. We said b was 1. I'll put it there even though we don't really need it. And now we're doing x is to the right by pi. Now I'm doing this with this factored out form here. Even though this is 1, it's really not necessary. I'm just always going to build them like this because this is the form where you won't mess up the shift. And then we have the 0.5 on the end. So there's our equation. Let's do another one. Okay, so now they told this one has to be a sine function. I don't know if the other one did. I think it didn't. So we know that we're going to have to be working with a sine function. So first of all, let's find our midline here. Do you see that our midline is running through here? So I guess it helps to start with this, I suppose. So our midline is y equals 2. So we've moved this up 2. Now if that's our center line, how high and how low are we going? Well, we're going 1. We're going up 1, down 1, up 1, down 1. So our amplitude is 1. Okay, now let's find our period. And if you're finding the equation, this is a little weird. But so our period here is going to be how long does it take to repeat? Well, we went up, down, here. So from here to here is one full cycle. From there to 2 pi. So that's just our normal period, 2 pi. Now, none of these have been very hard. So, but the equation needs the value of b. So we're solving this for b. So 2 pi divided by b is going to be the period that you read off the graph. That's the period off the graph. Well, it is 2 pi, so once again, b is just going to be 1. So again, I needed that for the formula. That's the number that sits in front of x. Okay, what do I got? So let's do, well, do I have any horizontal shifts? Well, if this has to be a sine functions start at 0, go up, go down. This is a sine function, then this doesn't have any horizontal shift. It does have that vertical shift that we already talked about. It's up 2. So we move this whole graph up 2. Okay, so we've got a sine function. We've got everything we need. We got y is, the amplitude is just 1. Wouldn't really have to write that. So in sine, the b is 1. Again, I don't have to do that for this one. I'm going to just be consistent though. Well, there was no shift there, so there's really nothing to write. Yeah, did I miss anything? I don't think so. Okay, so this is just, I'm going to simplify this now since I got a bunch of parentheses I don't need. This is just sine of x up 2. That's all it is. So that was pretty easy. Okay, hopefully this one will be harder, but not too hard. Let's play the game again. Try to make an equation for this. So let's first find where it's centered at. If you think like the halfway point, if we folded this down, it appears, am I right, that Yeah, there we go. Okay. So this is where I'm folding this thing at. So my midline is going to be y is -2. Now the reason I need that is so that I can really understand the amplitude. The amplitude is how high and how low you're going. Well, I'm going up 3, down 3. So my amplitude is 3. Now I think we're going to get a little more challenging period here that'll help us. So we need to see where we repeat one full cycle. Now if I tried to start at the beginning, that isn't going to help me very much because I can't really read it. So I'm going to start here and see that I've gotten through a whole cycle at 7. So what is that length? How long did it take to repeat itself? It took 6. From 1 to 7, my period is 6. Okay, now we've got something that's a little more challenging. So if the period is 6, we need to find b. Well, it started as 2 pi. We divided it by that horizontal stretch or compression. So we're dividing it by b. That's how we came up with 6. 2 pi divided by whatever in front of x created 6. Well, let's solve this. 2 pi equals 6b. 2 pi divided by 6 equals b. So b is then, b is then pi over 3. Now this asks for the period, but if I'm making the equation, I would need this. Again, I don't really ask for this anymore, but if you're doing this at home, there you go. Okay, so what else do I need? Now I'm going to just go and do the vertical shift next. So we move this thing down. So it's normally here, it moved down 2. So my vertical shift down 2. Now we've got only one thing left, horizontal. Okay, this thing has been moved off the starting line. Now, oh, they do want a sine. That is going to be hard to read here. I don't know if I can tell. Hold on. Cosine would be much easier here. Yeah, I could do that and be sneaky. Hold on, let me see. Yeah, I'm going to switch this to a cosine and show you a trick if I go. So if we were doing a sine, this would be my starting point, and I've moved back. But the problem is I can't read how far I've shifted back. So instead, what I'm going to do is I'm going to think of this as a cosine that has moved. So here would be cosines start at the top and go down. So a cosine would be much easier to read. I can tell that this has moved right 1. So we're going to make this a cosine even though that's not what they said. So we've gone right 1. Okay? All right, now let's build this as a cosine, and then I think if I can think this through right, I don't do this very often, but let's build the equation. So I've got y is an amplitude of 3. We are going to call this a cosine. And the number in front of x we said was pi over 3. Now we've got a shift this time. We are going to go right 1. And then we've got the down on the end, -2 there. Okay, so I'm trying to think how far off. Yeah, there's a difference of pi over 2 between sine and cosine. So we could try adjusting this. I'm not going to do it. I'll look at theirs here in a second, but I don't know how they found this to be a sine function without starting with this and adjusting. So I would have I'm striking this off of there. Just find a function because the cosine here is going to be much easier. Let me see what they did here. Yeah, they did cosine. I'm not sure. Okay, so they did cosine anyway. So, yeah, they did cosine anyway. So, same thing. Okay. I think we have a couple more here, so let me take you through this. Let's do another one, hopefully, or if you want to, pause the video and try it yourself. First thing, I'm going to go ahead and do the midline because it helps me show you where it's centered at. So, can you see that if you folded this thing down, that would be the halfway point. So your midline here is now at y is 4. So amplitude, how high are we going up and down? Well, if this is our midline, we're going up 4 and down 4. So my amplitude is 4. What's next? How about the period? The period is from a top to a top. So this one's a little hard to read. I'm assuming that's -7. Man, that is hard to tell what they're doing. Okay, I guess they're going -7 to 3 would be a place that we could get a whole cycle here. I think that's what it's supposed to be, -7 to 3. So our period then is 10. It's a length of 10 to get from those two. From a top to a top. It looks like we're just calling it 10. So our period there is 10. Now we're making the equation, so we've got to do this. 2 pi divided by b is what made the 10, where b is the number in front of x. So we're going to solve this. We're going to get 2 pi over 10 equals b. So b is pi over 5. I don't know if that's really what they meant it to be, but okay, so we're saying b is pi over 5. A little weird, but that's how it plays out. So let's see. Yeah. Okay. What else we got to do? We got to do our vertical and our horizontal shifts. So horizontal is easy. We've gone up 4. So up 4. Now, how about vertical? No, I'm sorry. I've reversed these words. Our vertical is up 4. Our horizontal shift is our right and left. Now, it is easier. You could think of this as going left or right because it keeps repeating. I'm going to take a cosine again because it's easier to work with. And I'm going to say a cosine, which always starts at the top, has been moved forward 3. I don't know if that's supposed to be, I don't know where that's supposed to mark, but we're going to say a cosine that starts at the top has moved forward 3. So right 3. Okay, so we got everything we need. Y equals 4. Cosine of b, we turned out to be pi over 5. X minus 3, because we're going to the right, up 4. Again, there's different versions. You could have thought of this as going back because the thing keeps repeating. You could have made a sine function, but the cosines are the easier ones to work with. And there we go. Okay. Well, there's more to this. This is getting to be a long video. So, hold on. Let me see how much we got left here, because this is a lot. Okay, this is taking a long time. So let's keep going. So we're going to graph this function. So notice the amplitude is 0.8, but the minus means that we've flipped upside down. So we're doing a cosine that has flipped upside down. So let's do all this here. My midline is still just going to be 0. Oh, no, it hasn't. Sorry. No, it is. Sorry. We don't have any vertical shifts. So my midline is just going to still go through y equals 0. Now my period this time, they told me the value that's in front of x. It's 2. So that's when we do 2 pi divided by that b. That's the b right there. So my period here is going to be pi. So this thing has been compressed. Okay, amplitude is 0.8. Now, it's also flipped upside down, so be careful of that. And we don't have any right or left shifts. Okay, so let's start building. All right, so first of all, this is going to go up to 0.8 and down to -0.8. Now we're doing a cosine function, so cosine functions usually start at 1 and then they go down. So they start up and go down, but we flipped this upside down. So we're now starting, we've turned a cosine function upside down and we are starting here. Okay, now our period is pi, so we have to go through the entire cycle of the cosine function by the time we get back to pi. So we're going to go up here and down there. That is terrible. Up there and down there. So the entire cycle had to be complete. The up and the down had to be complete by the time we get back to pi. Now this is it. So we've turned it. So cosine, usually, you got to remember where the basic functions are. So cosine usually starts at 1, goes up and down. Well, we've turned it upside down and the amplitude is 8. So instead of starting at the top, he's starting at the bottom. And our period has told us the entire cycle has to be done by the time you get to pi. and then it'll repeat from there. So again, terrible looking graph, but that's it. Okay, a couple more of these. I forgot that I could get these nice pretty graphs out of the back of the book, but okay, so let's do our midline here. Midline is going to stay at y is 0. There's no vertical shift. Our amplitude is going to be 2. Notice that it's flipped upside down again. That negative means we flipped it upside down. Now let's do the rest of it here. So I'm going to make this the form I like, where I'm going to pull out the pi over 3. So if I factor out a GCF of pi over 3, I'm really dividing. Oops. Hold on. I'm dividing that pi over 6 by pi over 3. That's what it means to pull out a GCF. Now that's a fraction, so I'm going to keep change. Oh my gosh, I'm sorry. Getting this wrong. The video has gotten really long and I'm getting a little tired, I guess. Okay, so the pi's would cancel out. This is going to be 1/2. So if I pull this out front, pi over 3, then I've got a plus 1/2 sitting out there. Okay, so my amplitude is 2. It's flipped upside down. My period is 2 pi divided by that number sitting in front of x, which is pi over 3. So we flip that upside down, and we are going to get 6 here. If you flip that upside down, you'd have 2 pi times 3 over pi. You're going to get 6. So my period is 6. Okay, we don't go vertically up or down, but we have shifted left by 1/2. It's a left because of a plus there. Shifted left by 1/2. Now, I wish I had remembered that I could have taken the nice, pretty answer to this out of the back of the book. The shift ones are difficult here with the right and left, so I'm going to deal with that first. Okay, so we have moved back. So we're going to call this 1, -1, -2, etc. So I've taken a cosine function and moved it back 1/2. My amplitude is going to be 2. So I don't know if you can follow this. Again, I should have posted the right, their pretty one that would be out of the back of the book that's done by computer. But so I've moved back 1/2. That's what this is telling me. So I'm going to start my graph back 1/2. Now, it's going to go up to 2 and down to 2, but it's turned upside down. This is a cosine function that's been turned upside down. So I'm going to start at the bottom instead of at the top. I'm starting there. Now, when I get through a period of 6, I need to have done the entire cosine curve. So if this is 1, 2, 3, 4, 5, 6, and I started at 1/2, at 5 1/2, I need to have done the entire cosine curve. So I need to get, let me see here. Yeah, at halfway it needs to get all the way up to the top, all the way back down to the bottom. Okay, so then it would just keep repeating. So when it took 6 steps, it needed to have completed the entire cycle. So what's weird about this here is that this is a cosine turned upside down. So this is the graph. Sorry that this isn't very pretty. The back of the book has the try it now answers if you want to take a look there and see this in a little more attractive format. Okay, last thing here. If I ask people to graph the functions, this is all I would ask them to do, is basic ones like this without shifts. This is a cosine function with an amplitude of 7. So after all those crazy ones, it's kind of funny that we just start with something easy, or end with something easy. Okay, so cosine functions start, cosine functions start at the top and then they do this. Well, if the amplitude is 7, I'm now starting at 7, and then by the time I get to 2 pi, I need to have gotten all the way through the curve. So cosine function is going to go down to -7, back up. Again, you'll see this more clearly. I should have, I'm freehanding this. This should have been halfway here at pi and then completed at 2 pi. That would be an entire period. Again, I wish I would have done this. I should have taken the pretty graphs out of the back to show you them in a nice way. But you can find those in the answers to the triads at the back of the book. Okay, super long video. I hope that made some sense. I know that's some hard material. Hopefully you followed me on that.